So at first, for the people that are not so familiar with Haber and Böcker, only one slide. So we started producing machines 1887. Our head office is in Oelde, Germany. We have worldwide around 50 locations, 2,850 employees, and a turnover of the complete Haber and Böcker company of around 500 million euro. We are working in the following areas: chemical and salts, mining, cement, minerals, and recycling. So these are the main areas where we supply equipment for. For these areas, especially for the chemicals, mining, and aggregates, we make this presentation today. So we want to discuss a little bit about efficiency long time ago. So this picture is probably for some of you also familiar. We take it from our mathematics books at school. At that time, a long time ago, even so, I asked myself, for what can I need this picture, or for what do I need this? Years later, now I understand why I need this. So 4,500 years ago, the people built in Egypt the Great Pyramid, the Cheops Pyramid. For that, they use around 5 million tons of stone. They make the pyramid in 30 years. Oh, so this was really efficient for that time, because the idea was to make, let's say, like a cathedral for the pharaoh. 4,500 years later, people make another type, let's say, of cathedrals or something like this. When we take this picture and invert the Cheops pyramid, so it is on scale, the pyramid in that case. So people in Brazil make in the 1980s, in 3 years, they move the same quantity of material, even more, 7 million tons, in only 3 years. So this was also another kind of efficiency, because they use the same tools like the people that build the pyramids. That means they use their hands, no machinery, nothing. But then they create this big pyramid of material that they cannot use because they only wanted to have the gold. This make in 3 years. Nowadays, we have another efficiency. That means we have plants and machinery that move the same quantity of material in 1 year. So that means that efficiency is higher, but we use less manpower, but more machines. Why I show this, I'm sorry, why we show this picture? This picture is shown so that you can see that we also create, with these big amounts of material that we move, big pyramids worldwide, not only in the Sahara, but also in the north part of the earth and in the south part of the earth. Even this is not a big plant, because 1,000 tons per hour is a small plant in mining scale, but for aggregates, it's a big one. So why we want to need or that you increase the efficiency. We want to avoid to create these big stockpiles of material that no one can use. So when we see these stockpiles, because we can do nothing with these stockpiles actually, we have to ask why or where it comes that the processes are so inefficient. What are the causes for that? The causes normally comes, part of them, for example, from the feed. So depending on the material that comes from the quarry, because the feed changes constantly, the mineral content of the deposits changes also constantly, and the use processes and others are also changing even during operation. So this is the reason for this picture and causes why we have this big amount of stockpiles of not used material. When we go, and we see at the geological part of a quarry, so we can see that the first steps is to remove some materials that we don't want to use or cannot use. So this is part of the geological things. So then we have the customer. The customer, or let's say the customer of the quarry, they want to use only normally one material from the quarry and not all, because they have requirements for that. And then we have environmental issues. So this means that in some areas where it is not restrict to keep to dump the material that they don't need, so they put it aside, and then you create again big pyramids everywhere in the world. So now we came back to part 1 and part 2. I don't know if you have the possibility to follow my colleague, Dr. Rüdiger Einrich, during the presentation of near flow. So near flow is for me, or for us, part 1, because there we show you how to select the machinery for your quarry. So this is why we put this picture to come back again. So we have a system, or let's say we have a software to calculate the machines for your quarry, screens, crushers, feeders, and so on and so on. And the system gives out what materials you can expect to get from your quarry, of course, considering your inputs to that. After you choose your equipment and you design your plant, you choose the right equipment for that. So you choose your trucks, you choose your screens, you choose your crushers, filters, conveyors, and so on. So all this is equipment, you choose it when you build your quarry. So after it is built or you design it, so you make at that time the ideal process. You have the ideal quarry, you have the ideal equipment. So, and you don't go to change it every day. So it is constant there. Now you have your equipment in your quarry, you have your feed, you have your geological issues, and so on. and you have a lot of components inside of your equipment or already installed that you don't use. For example, sensors. So this is the point, or this is the key that we want to use to increase capacity and output, let's say, of the quarry. So you are prepared but not connected. You need to use it. What does it mean? So this means that, for example, you get, when you buy the equipment, you get proximity switches, temperature sensors, you get electrical controls and monitoring for your machines. You get vibration, acceleration, and speed sensors. All these things you get with your new machines that you choose at the beginning. Or even, for example, pools. This is a system from us, from our Böcker. You get it, you put it outside. This is, for example, a picture of a machine running with such a system. So it is not something that we only assume. So the people use it, but only for one thing. Only, let's say, for example, for vibration. But we can use it for more. We can use it for increase the efficiency of your plant. How to make that? Our experts from Haber Automation are able to connect all these installed sensors from your machines to a complete system. Electrically, control systems. We can make it in dispatch, not only in the production area, connecting ERPs and DCS. And if the customer wants, we can make it also in remote mode. That means using a cloud. But I know clouds are sensitive things, so it depends if the people really want to use it or not, because I know cloud is sensitive because of the data. So this is a picture that everyone of us see when it goes in a production area. So we see all the machines and we can see what machine makes for its alone, but the machines don't, let's say, don't speak together. So this is, for example, when we supply a screen, the amount of things that usually we supply with the machine, even if the customer want to use it or not. So these kind of things are state of the art. Let's say we supply it together with the machine. Now we came to the idea of I4. Why it is necessary? So this is necessary so that the machines can, let's say, speak together. This is what is behind that. This is the idea, so that you link your machines so that the crusher know what is the screening machine doing and the machine knows what is the belt conveyor doing. So why we have to use it? So we can use it, or we should use it, because, for example, the ROM from the quarry changes frequently. So these decrease your output on material if it goes in the wrong direction. The reject increase, the quantity of lost material increase also. So this means these stockpiles becomes bigger and bigger, and we are back to the pyramids. Why it is so? In these pictures we can see it. Sometimes we get this from the quarry. Other days we get that. Big amount of big stones and only small amount of fine materials. Rainy seasons in some areas of the world, and especially also in the mining, we get this kind of material. It looks more like a pudding than like material for the processing of a quarry. So how do we want to connect you? Let's say that the machines know what they are doing. So the first step from our side is to make images of the material. This is why we put this nice camera here, because everyone understand, okay, it is a camera. So we want to make pictures or images, analyze it, and see with this, let's say, analyzing, we can see how does the material looks. We can analyze it direct at the feet. If we go on with your process after the first step of screening or crushing, again we have the feed to the second step, and then of course we get out bigger or coarser material, overs, and we get the fine products, the passings. This is our first step, what we want to do. So where we can install this type of cameras? We can install it over belt conveyors, over stockpiles, or even over trucks, chutes, and so on. So we have the camera, we have a light, and we look at the material. What we get out? We get out particle size. We can identify some materials. We get out the maximum and minimum averages of the sizes. We get these pictures in real time. That means direct. We can provide it for other issues in the process. We have this shape distribution of the material, volumetric information, and even contaminations, for example, big pieces of wood or some things like that. So here we have a picture, for example, of a stockpile. Here you have your loader, and this is the picture what the camera sees. So again, we take the camera and go back to our feeding point. There we want to use this so that we know what comes into the process. This analyzing, and then we get out the curves, the distribution curves of the material that comes into the quarry. After the crushing, for example, after the first or the primary crushing, we analyze again with another camera what's going on the belt conveyor that comes from the crusher, from the primary crushing station, before it goes to the secondary and to final screening. Again, we see, okay, we get another distribution. So this is our first step, what we want to do, so that we can control and see what you get out of your plant if you are inside let's say, of the limits. We can make this control before, for example, screening, or even after the screening. After we have done this and see what going on before we have, let's say, one operation step, we can recheck how the material really looks like. This we can do it, for example, with our system CPA. So CPA, what it is this? CPA is a system that is not direct over the belt conveyor or over the chute. It is a system that can be used in a laboratory or even online. So we measure the material. We get a small amount of material. Again, we take pictures, but then in small scale, and we see what happens. Why we do this? We do this again to get out the distribution, the material distribution, PSD curves, but also to see what is the shape of the material. It is round, it's square, it's oblong. So all these things we can get out of this system and then compare it with what we want to have. What are the advantages? Advantages are that we can make this and control the process direct online or even a laboratory at short time. This is the advantage of this system. So now this was the theory, but of course we came back to real cases. So for that we choose a case that we make in Switzerland years ago. What was the idea? The idea was to increase the output of track ballast, adjust the capacity of crushed sand, and provide high quality products. So these were the points that the customer want to have, especially regarding track ballast and quality. So this is something, this is together. So you must have the quality, otherwise you cannot sell your track ballast to the companies that, let's say, make new tracks or even recycle the material from the tracks. So we look at the area of the track ballast. So we get from the first step of crushing a 080. We only want to have for sand production the 032. Our track ballast is the 3250. So this, the track ballast, is the material where you can get the money out of the quarry, because sand, there are also a lot of other producers around this quarry. So here we have a picture of the quarry. So if we go back, so you have the silo inside of the house, there is the crusher and also the screens. So we have the silo, and inside we have the crusher and the screen, let's say for track ballast. Outside we have the stockpile, again our pyramid of material. Let's say it's not really a pyramid, but okay, it looks like, of the track ballast. So the idea of analyzing images, we do there. So we check the material, analyzing the images, but efficiency is more than that. It's not only analyzing the images and say, oh, okay, the crusher must run faster. Also, the screens must be adjusted. So that means we have it here. What happens? If we play with the crusher, in that case, this case study, so then we are, let's say, facing problems on the screening area, especially also on the sand side, because sometimes it comes too much sand, sometimes it was not enough sand, or even the quality was not okay. Because the screens, in that case, there are 3 screens screening this material, and not all screens work in the ideal conditions according to the, let's say, to the game that a customer plays with the crusher. So for that, we make a long time study. Long time, it means 1 month, to see what happens when they modify the crusher, to see how to adjust, let's say, the screens. So we start, for example, it was not example, we started in February, and then we go till March, check different possibilities to adjust the machines so that all machines work on perfect conditions, even when the customer modify the crusher. So this is what it means. Efficiency is more. It's not only images and say, okay, this is the PSD of this material. No, you have to play, let's say, with some parameters on the screen side. So this is part, let's say, of the near flow also, that these parameters are included in the selection of some equipment. So, for example, we have to play with the RPM, with the speed of the machine, with the amplitude, with the acceleration, and in some cases with the movement type. It means if it is linear, circular, elliptical. So some machines have the possibility to play with these figures. This we need to do to prevent or to reduce adverse effects on the screening area when we change or modify parameters, for example, on the crushing area. Because what we want is to get products that your customers need. And again, we are back to this picture. So it's not only to supply the screen with a motor, so we can or we should use all these sensors included to adjust the machine, to adapt it to the process. What is the main point? The main point is really to get out, in that case, in Switzerland, to get out this material. Every one of us know that or see it, but it is a very, very important product. And if it is not correct and not good enough, you cannot use this type of trains. So you see, it seems it's only crushed stone. Yes, it is crushed stone, but it is important how this product looks like, even to, let's say, to drive with 300 or more kilometers per hour. So this is, for example, or let's say this was an example where we use this technology and use the sensors installed at the machine to adapt it to the process. So efficiency is more than higher capacity. So this is what we want to say. Adjust the machines is a need to get better products, to have a good and preventive maintenance, increase the lifetime of the equipment, because it makes no sense to, let's say, accelerate a screen up to 6, 7, or 8G and every month changing bearings and other parts. So the machines should run with the possibilities given by the technology. keep production costs lower, get maximum of product, reduce volume of no commercial material. Okay, now we are back to my pyramid. So again, we see it here. If you don't use the possibilities given by the technology, so you get your pyramids bigger and bigger. So it doesn't matter for us if the product is round or square. So we can check even round or even square products. For the technologies, it doesn't matter, especially for the technology, let's say, to make images during the process. So these are some pictures of products that we already control and that we already manufacture and, let's say, check the process with the technology and with the systems. So you see, so it doesn't matter what you have, we can use the technology. We can use the technology online or even offline. Offline means we take it from here, from the storage, bring it to the laboratory and check it there. Or install the camera over the storage and check it. So this is one possibility. The other online possibility is to use it direct during the production of the materials, and not only later when they are, let's say, in the boxes or in silos or even in stockpiles. Again, we see it here, let's say, online systems. How we can do this? For this, we want to show you a small, short movie, what is possible to do. So this was a small movie, let's say, to show what is possible to do, let's say, online, direct during production. And it doesn't matter for us if you say we want to make horizontal integration in our quarry, in our factories, in our production lines, or if we want to make vertical integration. It doesn't matter, we can make both. We have the technologies inside and we have the expertise for that. So produce what you want and where you want. We will support you with our different technologies and with our expertise for that. So this is also a picture for production of to make the products direct where you have your resources. You see, it is direct in the lake where you get your material from, you crush it, you screen it, but you don't want to keep big amounts of material back into the lake because you spend a lot of money to get it from the lake. So thank you very much for your attention. And if you have any questions, or even if you want to give us some suggestions, we are open for that. Thank you very much. And if there are questions, so please, you can send it or give it to me. Otherwise, thank you very much. Have a nice day and take care. So, and after I switch off my camera, then I can put my, let's say, my mask again on. So, but I don't want to do this so long we are online. Thank you. Okay, thank you. Have a nice day again. See you by the next web seminar von Haber and Böcker. Bye. Take care.